Welcome to Pre-Calc in Pajamas. Hi everyone. I hope you watched my video last week. If you did not, try to. If you need a little refresher, this week I definitely need you to watch it because it's brand new material. We're jumping into, spoiler alert, trig on non-right triangles. So if you needed help answering your discussion post, yes, you can do trig without right triangles. But tell me why you think that's the case, because I'm going to go over something that people put in the discussion post the answer to next week. So I'm just gonna introduce two completely new concepts. They still use trig. One of them you're not going to mind. One of them you're going to hate. We'll get to that when we get to that. So, for starters, the topic of today is going to be the law of sines and the law of cosines. And these are going to be used with non-right triangles. So, the law of sines. There is two ways to write this. I'm going to show you both, but I'm going to favor one because of how friendly it's going to be on your phone calculator. So this is my favorite, okay? Sine of A over A equals sine of B over B, which equals sine of C over C. This does not mean you need all three. You can do it this way, you can do it this way, or you can do it this way. It doesn't matter. All it is it's setting up a proportion, which explains my discussion post about how to solve for a proportion. Because these are proportions, you could also write it like this. But because of your iPhone calculators, this is going to be a lot more complicated to type in as opposed to this. So some things you need to know: if it is lowercase, it's going to represent a side length. If it is uppercase, it's going to represent an angle. Cool. So sine of A over A equals sine of B over B, which equals sine of C over C. Again, you can write it this way, but for our sakes, it's going to be a lot easier. So you don't always use law of sines when you're dealing with a non-right triangle. You could also use law of cosines. But if you are a type of person that has been taking notes and been writing things down, I got notes for you. When to use law of sines. So there's two times you should use law of sines. You should use law of sines when you have two sides and a non-included angle. What is an included angle? So you see how I have this side here and this side here? This would be the included angle. This would be the angle in between. Because he is not in between my two side lengths, he is a non-included angle. Cool. The other time you want to use the law of sines is when you have two angles and a non-included side. So I have angle here, I have an angle here. This would be the included side, but I don't have that. I have a non-included side. And that is when you use law of sines. So let's jump in. We have the formula. We have when to use it. And I'm going to look at my handy dandy book with the 4 questions that I wrote down earlier and drop my marker as always. So let's just take a look-see. Okay. I'm supposed to show the triangle first. Whoops. So I have a triangle here. We may have to take a short break.
Good afternoon, insurance office. Can I help you?
And we're back! Kirk and I are both working from home, so sometimes he has to take a phone call. You guys don't care. But it did give me time to draw my first triangle. So as you can see, I have two angles. A non-included side, because this would be the included side because it'd be in between the two angles. And I want to solve for this guy here. So you can use the law of sines to solve for all of the sides, But let's not do that. Let's just solve for our missing x. So I have an angle here, I have an angle here, and I have this as a non-included side. And this is why the non-included side is important. Because the way that we're going to set this up is if I call this A, then that means the side across from A is going to be that little letter A, the side A. So whatever side goes across is going to be how you're going to set it up. So if this is angle A, this is side A. If this is angle B, this is side B, because I'm taking my finger and I'm dragging it across. Not that this matters, this would be angle C, and this would be side C. But I don't care about C, I just care about A and B. So I have angle A, boop, angle B, boop, and I'm going to set that up. So I'm going to do sine of 77 over 15 equals sine of 23 over x. If you called this A and this B, you still get the same thing, it's just flip-flopped. So it really doesn't matter. Just be consistent with A is across from A, B is across from B, C is across from C. Just be consistent. Okay, and now what I'm going to do is I'm going to cross multiply. So my 15 is going to go with here, my x is going to go here, and I'm going to make some weird looking algebra problem. So I'm going to have x sine of 77 equals 15 sine of 23. Now I just need to get x by itself. So this is when people get very confused, because now we have words and stuff, and we're like, well, I don't know how to get rid of a word. Just divide. Just divide. So that cancels out my sine of 77, and now I have 15 times sine of 23 divided by sine of 77. So you can enter this in on your calculator, on your phone, and I'm going to show you how to do that. If you have an online calculator, this is going to be way easier. If you have a scientific calculator, if you have a graphing calculator at home, even more easy. But I do really want you to try and calculate this out with your phone or with some sort of calculator. So we're going to turn it on when it works. I'm getting a new phone soon. So that's exciting. Okay, so I'm going to flip it. Remember, take off the lock screen. And then if I have 15 sine of 23, remember we're going to type in, let me put a blue box around it so you can see what's going on. That. I want to type that in. I'm going to actually type in the 23, then hit the sign, multiply it by 15, then hit divide, parenthesis, 77 sign. What? Yeah, I'm going to show you. This is why if you can find a calculator online, please use it. So again, 23 sine, multiply it by 15. I'm going to hit enter, and that's my numerator. So now I'm going to hit divide, and then start my parenthesis down here. 77 sine, close the parenthesis, hit enter, and I get 6.015. You can round however you like. Again, I don't care how you round. For me, I'm going to round to the 100th, so I'm going to call this 6.02. I like showing you both so you know that you didn't screw up, because everyone gets really weird about rounding. So here you go. I typed that in my calculator. I got that as my answer, and I just rounded it. Cool. So that's when I have two angles and a non-included side. So the other example I'm going to give you is when I have two sides and a non-included angle. And this is when we're going to solve for an angle. Yay! So I'm going to erase my board, Maybe next time I'll write a little bit smaller. Okay, so I have definitely a scaling here. Cool. So this is 78 degrees. And I'm solving for, yeah, let's call it B. This is my triangle. I have 78 here. Directly across from that is 34. That's a side length. This is not an 8. This is a B. But I think for the purpose of this, I'm going to change it. I do want to keep it B so that the formula makes sense. Maybe if I put B degrees, maybe that'll help. B degrees, great. And directly across from the angle B is the side length B, which is 18. So we're going to set this up the same exact way. Sine of A over A equals sine of B over B. Sine of A over A equals sine of B over B. Now, before I move on, I want to bring up something that is a very super common misconception. A lot of people will write sine of 34 over 78. And this is a big no-no because you can't do that with side lengths. You can take sine of an angle or side of a radian. Because we're working with angles, we're going to take the sine of an angle. Okay? So make sure that your angle is connected to sine and make sure that your side length is by himself. So sine of 78 over 34 equals sine of B over 18. That's fine for now. We're going to cross multiply. So that's going to give me 34 sine of B equals 18 sine of 78. The problem here is that now I don't have like a nice neat x by itself to isolate. I have to isolate sine of B all together. So isolate sine of B, I'm going to divide by 34 on both sides. So I get that this equals sine of B. And I'm going to use a little bit of color so it pops. So I get here. You know what to do. You just don't know that you know what to do. So if I'm solving for B, I'm going to take the inverse sine of both sides. That's it. That's all you have to do. So in your calculator, you're going to get the value for this messy part here. 18 sine of 78 divided by 34. And then you just take the inverse sine. So I'm going to show you how to do it on this calculator. Again, we're here. Going to clear it all out. I start from the sine. So it's sine of 78. So I type 78 sine. And then I'm going to multiply it by 18. Enter. That's my numerator. Now I need to divide it by 34. Enter. And I get like 0.517. You're not done. What you have to do now is you need to take the inverse sine. So I'm going to hit my second button. I'm going to hit inverse sine. And I'm going to get my answer, which is 31.18. And I'm going to round that to 31.19. Degrees. Ta-da! Here's all the work. Sorry that you can see screens in the background, like reflecting. I think you're all right. Okay, great. So, moving on. We did our two examples of the law of sines. And then, now I gotta teach you the one you will not like it. Actually, I take that back. Last year, some people preferred law of cosines. I don't. In fact, because it is so complex, I'm going to tell you right now, I will not be upset if you use a calculator online for this. will not be upset. I'm not going to show you how to do it on the iPhone because it requires so many different steps, and you're going to have to write down different numbers. And then with rounding, it's going to get a little bit crazy. So if you find a law of cosines calculator online, I really just, I don't mind. I just need you to understand the math behind it, and that's what this video is for. But because I know not all of you have graphing calculators at home, it's next to impossible to do it on an iPhone. So I'm not going to hold that against you. So let's take a look at when you can't use law of sines. Cool. Handy dandy calculator. Nope, not a calculator. I'm using my board. All right, so I have 37 degrees here, and 11, and 8, and the letter X. So the reason why I can't use law of sines here is because, to solve for X, I mean. So 37 is directly across from X. So I don't know what this side length is. 11 is across from an unknown angle, and 8 is across from an unknown angle. So because I have two unknown angles and an unknown side, it is impossible to figure out this side length or either of the two angles. And that's when our, I guess he's a friend, our friend law of cosines comes into play. And he is important here, even though I don't like him. So the reason why I don't like him is because the formula is this. The law of cosine states that, remember, if it's lowercase, it's the side length. C squared equals a squared plus b squared. So that's like Pythagorean theorem right there. You know that. You know that. You know this. But then they throw in this angle relatedness here. Yeah. So c squared equals a squared plus b squared minus 2 times a times b times cosine c. Whew! That is a lot. That is a lot. Don't get overwhelmed. I'm going to take you step by step. So we're going to solve for the side length here, which means don't forget at the end, if I'm solving for c, I need to take the square root at the end. And I hope I don't forget. It's very easy to forget to do that. So now let's identify our sides. Like, we're dealing with so many different things that I just want to identify my sides. So since I'm solving for c, the angle across has to be c. So that's my c, that's my c. And I don't care if 11 is a or if 8 is a. It will not affect the math. It doesn't. So let's call 11 a. And let's call 8 b. A and b. Cool. And then we're going to plug and chug. And it's gross, and it sucks. And I lost my black marker. No, I didn't. And we're just going to plug in what we know. So, formula is c squared equals a squared plus b squared minus 2ab cosine of c. We said a is 11. So 11 squared plus 8 squared minus 2 times 11 times 8 cosine of 37. I'm just going to show you this part. And if you need to pause here, please be my guest. I would recommend you pause so that you can make sure that you're following what goes where and why it's 11 and where did 8 come from and where did the 37 come from. Great, cool. So now we're going to use PEMDAS. We have to use PEMDAS because everything on this right side is stuff we can get a value for. The only thing we need to remember is just to take the square root of this at the end to get our actual answer. Thank God I've written it down. So 8 squared is 64. 11 squared is 121. So altogether, when I add those, I get 185 minus 2 times 11 times 8, which is 176, cosine of 37. And you can yell at me and you can tell me that I didn't PEMDAS because I did addition before I did multiplication. You can yell at me for that. But because of the associative property, it's okay to do these. Or is it commutative? One of the two properties, it's okay. You're all right. So 185 minus 176 cosine of 37. This is when you can use your phone. And I'm going to type in 37 cosine. I get 0.79, and I'm going to multiply that by 176. I get 140.559. So c squared equals 185. It's 140.559. Does round up to something else. 98, whatever. Cool. Great. That way we're going to be super close. So this here became the 140. So now I'm going to subtract. 185 minus 140.5598. And I'm going to get that c squared equals 44.4402. Remember, it's c squared. It's not c. My side length is not 44. And it wouldn't make sense either, right? Because this is a small angle. So we can assume this is a bigger angle because that's a bigger side. So this shouldn't be bigger than 11. Because just by looking at it, and I know it's not perfectly to scale, but by looking at it, the smaller the angle, the smaller the opposite side. The bigger the angle, the bigger the opposite side. So it would not make sense for x to be bigger than 11. So then I'm going to take the square root of both sides. And I'm going to get, when I round, 6.67. Also, something I noticed is that I changed the x to a c to benefit using this formula. If you kept it x, that's okay. Just please don't get confused with knowing what angle to use where. C equals 6.67. Woo! That is a lot. I know it's a lot. And that's why I only have one more for you. So the last one I have is going to be using the law of cosines to find an angle. And this is when I have to use this because it gets very complex. I need to be able to use the second button and hit the answer so that I can kind of continue the process. Well, let's look at the last triangle that I have for you guys. Thank you so much for listening as long as you have today. So, I have it's another scaling. That looks like a right, so I'm going to edit it so it doesn't look like a right. It's a little wonky, but you're fine. So we're going to call this 8, 9, 5. And I'm going to say that we're going to solve for this missing angle. So I have 5, 8, 9, and I don't know what this angle is. I can't use law of sines because I don't have any angles. So I have to use law of cosines here because I can have all all 3 sides and solve for an angle. Before I forget, because I totally did. This is when we can use law of cosines. And you can write this if you need to. So when you have all 3 sides, you can use law of cosines. Or when you have 2 sides and an included angle, see how it's in between? That's when you can use law of cosines. So if you need to pause and write that down, that's great, awesome, please do it. And moving on. So the most important thing here And anytime you're doing law of cosines is being able to identify which is which. So because law of cosines includes only one angle, cosine C, this has to be my angle C, which then means, boop, that has to be side length C. So let's write that. Angle C, side length C. And it does not matter. I'm trying to get myself right. I guess it doesn't matter. It does not matter if this is A, or if that's A, or if this is B, or if this is B. I don't care. I'm just labeling it how I see fit. So let's call 5A and 9B. Great. Now we're going to start with our formula. C squared equals A squared plus B squared minus 2AB cosine of C. Woo! Again, it's a lot. I know it's a lot. But the thing that's interesting this time is that instead of solving for C squared, we know what C is. So at the end, we're going to have to isolate this cosine C and then use the inverse function. So let's plug what we know in. So C squared is 64. A squared is 25. And B squared is 81. 2 times 5, 9. And again, I don't know what cosine of C is. That's really okay. So when I plug things in, this is what I've got. Okay? So now what I'm going to do is I'm going to isolate this by working furthest from the cosine C and work my way in. So I'm going to get rid of this 25. I'm going to get rid of this 81. I'm going to subtract them both on both sides. So 25 plus 81 is 106. So I'm going to subtract 106 from both sides. And that gives me negative 42 equals negative 2 times 5 times 9 cosine C. Gives me that. Ooh, that's a lot. So now what I'm going to do is I'm going to multiply these numbers together, 2 times 5 times 9. And don't forget the negative. So I have negative 42 equals negative 90 cosine C. Now to get cosine C by itself, I need to divide by negative 90. And this is why the negative is important. So that way I have a negative divided by negative, and it gives me a positive. So when I divide by negative 90, let me find out what it gets me exactly. I did it. Okay. So when I divide them both, it leaves me with 0.46 repeating equals cosine C. And then to get rid of the cosine, I'm so sorry. I'm almost done. And to get rid of the cosine, what I'm going to do is I'm going to do the inverse. So I take the inverse of 0.46, inverse cosine, I should say, of 0.46. And I get that my missing angle is 62.18 when you round degrees. Let me highlight that in blue. And show you the whole thing. I know this is a lot. Like I said, if you need extra help, you can always email me, or we can set up a Google Meet, or whatever you need. If you set up a Google Meet with me, I'd be happy to do some of the problems that I'm going to assign to you with you. I'd be happy to do that. If you are stuck on law of cosines because you just have your phone at home, it really is okay if you just find a calculator. I'm totally okay with that. I just need to make sure that you guys know the math behind it. So please watch this video. And if you need extra help, I got you. No worries. I miss you. That is all I have for you today. I will be in touch. Please email me if you need something, and I will see you guys later.